Hello friends, in my last lecture I have introduced the concepts of statistical hypothesis, mainly null hypothesis, alternative hypothesis, and the concept of p-value, and how to use that p-value to decide upon whether to reject or accept a null hypothesis. I had compared the concept of statistical hypothesis testing to that of a court case where the null hypothesis is the convict, and the evidence is the evidence provided by the data, and the strength of the evidence is measured in terms of the p-value. If the p-value is small, then the evidence is considered to be weak, and so we reject the null hypothesis. Whereas if p-value is large, then the strength of the evidence supports the null hypothesis and we do not reject it. Of course, there is one point that what is small and what is large p-value, that is, for that we need a benchmark, and I told you that um, that is something we will discuss later on. That is what exactly I am going to talk about today. But before we understand that benchmark, it is important to know two more important concepts in hypothesis testing. There are two types of errors: type 1 error and type 2 error. So understand these two errors with this example. Suppose I have a coin. I know that it is a fair coin, but I don't tell you. I just ask you to verify whether it is fair or not based on 5 tosses. Outcomes of 5 tosses, which suppose turn out to be all heads. Now you don't know whether the coin is fair or not, but you have seen that 5 tosses have resulted in heads. Now imagine that you are having to take a call whether the coin is fair or not. What would you do? So naturally, I had told you that we first need a test statistic. In this case, the obvious test statistic is the number of heads out of 5 tosses, and that follows binomial distribution with parameters. What will be the parameters? Number of tosses 5 and p. What will be the p? P is the chance of head. So under null hypothesis, the null hypothesis is that the coin is fair, so p is equal to half. So this will be the probability of getting 5 heads in 5 tosses where the coin is fair. And what is that probability? That probability is 1 by 2 to the power 5, 1 by 32. So now if you think that 1 by 32 is a number that is small enough, or it's not substantial, then according to the rule that we have discussed, then we say that the evidence does not support the hypothesis, and so we will end up rejecting the null hypothesis. But I told you in the very beginning that I had given you a fair coin, but I have not told you. So, but based on whatever evidence you have seen, and you have computed the p-value, and you found out that the p-value is small. Now of course it is debatable why did you think that 1 by 32 is small, but anyway, let us suppose we have reasons to believe 1 by 32 is not big enough, so therefore we rejected the null hypothesis. But in this case we have committed an error. What error? That whatever be our testing mechanism, we have ended up rejecting a hypothesis that is true. So such an error is called a type 1 error. So a type 1 error occurs when a null hypothesis is rejected, although the hypothesis is true. And the probability of this error is called the level of significance. Now the level of significance is also referred to as size. Of course, the size of a test is slightly more complicated, but as of now, since we are talking about only simple null hypothesis, that is where you test whether a population parameter is taking a specific value, so they are one and the same. So size of a test and the level of hypothesis at this level are one and the same. So the idea is, ideally I would like to eliminate such a error, but unfortunately it is not possible to construct a statistical test where you can completely eliminate the chance of this error. That is, it is not possible to come up with a statistical test where the level of significance is 0 or the size of the test is 0. What you can do is that you can fix the level of significance at a desired level. So generally you will hear 1% test or 5% test. So this means that the level of significance is fixed at 1% or 5%. And once you say that I am doing a hypothesis testing at 5%, then that means you accept in that test 5% as the chance of a type 1 error, and then you compare the p-value with the benchmark. That is, you benchmark in that case is the 5%. So the level of significance is used as a benchmark. So this is up to you. So you can take 1%, or you can take it to be 5%, or you can take it to be 10%. And once you have the p-value, you compare it with the level of significance. So if the level of significance if the p-value is less than the level of significance, then we say that the null hypothesis is less likely to be true as suggested by the data, or the evidence is against the null hypothesis. So if p-value is less than the level of significance, then we reject the null hypothesis. Otherwise we do not reject the null hypothesis. So higher p-value higher than the level of significance is interpreted as evidence in favor of null hypothesis, and value of p-value less than the level of significance is interpreted as evidence against the null hypothesis, so it is rejected. So this is how actually the testing of hypothesis works. Now there is another type of error that can happen. It is the error where you do not reject a false hypothesis. So suppose I have a coin where the chance of getting a head is 55%, so it is biased. But I again don't tell you that, ask you to toss it a small number of times, say 5 times, and you get 3 out of 5 heads. So then what would be the p-value? So then p-value would be the probability of getting at least 3 heads in 5 tosses of a fair coin, because null hypothesis is it is fair. So I ask you to, I leave it as an exercise to compute that value. It will be what? NC3 plus NC4 plus NC5 divided by 2 to the power 5. Now compare it to, suppose I say that level of significance is 1%. So compare it with 0.01. And in that case you will see that this p-value is more than 0.01. So you what would be your conclusion? Your conclusion would be that the strength of the evidence is in favor, or there is no reason to reject the null hypothesis, because the p-value is bigger than 1%. So you will end up not rejecting the null hypothesis. But I had told you in the beginning that the chance of getting hit, I have given you a biased coin. So you have ended up not rejecting a false hypothesis. So this is called type 2 error. Again, we would like to eliminate this type 2 error, but unfortunately again it is not possible to construct a test where you can make the probability of type 2 error 0. So we can try to minimize the probability of type 2 error while keeping type 1 error at a fixed level. Again, an important disclosure here, that even it is not possible to construct a statistical hypothesis test where you can minimize both the type 1 and type 2. Even that is not possible. So you cannot even construct a statistical hypothesis test where you can minimize both type 1 and type 2 error to the maximum extent. That is not possible. We keep type 1 error fixed, try to minimize the type 2 error. Now why try to minimize the type 2 error? Well, because we consider the type 2 error to be more serious. Just to motivate, why is that so? So suppose we are taking an interview to recruit a candidate. Now suppose you have a number of candidates who qualify a basic cutoff, and then interview is the final deciding step. In interview, you ask the candidate finitely many questions and see how he responds, right? So if a candidate does very well in that interview, then you recruit him. Now if it so happens that the candidate on a given day does not perform very well in the interview, then he may be rejected although he has the required qualification and capability. So in that interview you have rejected a capable candidate, suitable candidate. So what kind of error that will be? Obviously that is a type 1 error. But suppose the other possibility, that in the interview you end up selecting a candidate who is not suitable for the post, then that is similar to your type 2 error. But which error is more serious? Obviously it is unfortunate if a suitable candidate is not selected, but it will be disastrous if a unsuitable candidate is selected for a job. So this is one example which motivates why type 2 error is considered to be more serious. So in statistical hypothesis testing, what we try to do, ideally design a test in such a way that the chance of type 2 error is minimized and the chance of type 1 error, the level of significance, is fixed. Now how we do that, those are technical details. Those we are not going to study in that course, because for that you need to study in fact you need a full semester course on hypothesis testing. That is not our goal here, but we have to know the basics. So you know that when you have a test, whatever test you are doing, you have to choose a test statistic, and then today you will have softwares to help you out to compute the p-value, and then you have to know that what to do with the p-value. You compare the p-value with your desired level of significance. So if you are doing a 1% test, then compare it with 0.01. If you are doing a 5% test, then compare it with your 0.05. And if it is more, then do not reject the null hypothesis, otherwise the null hypothesis is rejected. I'll just leave with a food for thought. Suppose you are doing some testing of hypothesis and you find the null p-value to be more than 1%. So for a 1% test, you do not reject it. Now if you increase the level of significance from 1% to 5%, the data and the hypothesis remaining the same, what will happen?